For a right angled triangle with one angle of 30 degrees, opposite side lengths and hypotenuse give us the sine ratio. So we have the sine of 30 degrees equals 1 on 2. The 30 degrees and the 1 on 2 go together. We can do the opposite of finding the ratio. In this case we can find the angle from the ratio. And we use the inverse function for that. The inverse sine of a half is 30 degrees. The inverse function gives us the angle from the side ratio. In a right angled triangle with angle 60 degrees, the adjacent side and the hypotenuse give us the cos ratio. So we can write out that the cos of 60 degrees equals A on H, which is 1 on 2. We can take the side ratio and find the angle by using the inverse cos function. The inverse cos of a half equals 60 degrees. The inverse function takes the side ratio and gives us the angle. In a right angled triangle with a 60 degree angle, the opposite side and the adjacent side are in a ratio that gives us the tan function. So we have tan of 60 degrees equals O on A, which is 1.732 over 1. We can find the angle from a given side ratio using the inverse tan function. So the inverse tan of 1.732 on 1 equals 60 degrees. We can use the inverse tan function of a side ratio to find the angle. In this right angled triangle we have the opposite side 2 and the hypotenuse 5. So we're dealing with sine. So we can write out that theta is the inverse sine of the side ratio 2 to 5. On a calculator, this is equal to 23.58 degrees. In this right angled triangle we have the adjacent side length 5 and the hypotenuse 8. Since we've got A and H, we've got cos. We can write out that theta is the inverse cos of the side ratio A on H, which is 5 on 7. On a calculator, that's 44.42 degrees. In this right angled triangle, we have the opposite side length 5 and the adjacent side length 9. Since we have the opposite and adjacent, we're using tan. So theta is the inverse tan of the side ratio O on A, which is 5 on 9. On a calculator, that's 29.05 degrees.